Hi everyone, Mrs. Gamble here. I'm sorry I'm not in class today, but I thought it would be helpful for me to go through the study guide in case you are needing some extra support. So the first thing in the study guide, we have all of the different rules, so let's go over it. The first rule, the product rule. If you have the same bases and you're multiplying those bases, what you do is you keep the bases the same. So we're going to be keeping the bases here x. Oops. And we take the exponents and we add them. A plus B would be what we would simplify this exponential expression to be. The power rule, we keep the base the same and we multiply A times B together. This would be x to the power of AB. The quotient rule, we keep the base the same. Notice the bases always stay the same. And we subtract the exponents. A minus B. The negative exponent rule, if you have a negative exponent in the numerator of a fraction, what you do is you bring that down to the denominator. It then turns positive, and that's how it's simplified. If you have it in the denominator, for example, 3 over x to the negative a power, to simplify that, you move it up to the numerator, and it turns positive. Adding and subtracting monomials. Basically what you do is you add or subtract the coefficients and keep exponents the same. We see an adding and subtracting monomial situation in number 1. 6ab minus 8ab. 6 minus 8 is negative 2, so this combines together to be negative 2ab. For number 2, we have two pairs of like terms here. The first and last are like terms because they have the same variables and exponents, so we can combine those together. Negative 2 plus 6 is 4, so this would be 4xy squared. And then we have that minus 4xy that cannot be combined with anything else, so that would be your final answer. Of course, in any order would be fine. Subtract negative 6b to the 5th from 8b to the 5th. We would take 8b to the 5th, and we would subtract negative 6b to the 5th. Minus negative really means plus. This would be 14b to the 5th power as our final answer. Starting at number 4, we're not adding and subtracting anymore. Now we have multiplication, division. Sometimes we have some addition in the end. But number 4 starts the different rules we have to figure out to use. So the first one we would use in number 4 is product rule. We can multiply the negative 7 and the 5 normally. That's negative 35. But we would use the product rule with the like bases and their exponents. We keep the n the same and we add negative 4 plus negative 2, and that's negative 6. But wait, we cannot have a negative exponent. So to simplify this, we take that n to the negative 6 power and we move it to the denominator. The 35 stays in the numerator and n to the power of 6 gets moved to the denominator. Oops, I forgot that it's a negative 35, so keep that negative in front of the 35. Number 5, we have a power rule that needs to be completed first. So we first would do 5 squared and then v to the 8th, since the power rule says multiply the exponents. And then rewriting the rest of the problem, we have this. 5 times 2, or sorry, it's not 5, it's 5 squared. 5 squared is 25, and 25 times 2 is 50. And then for the v's, v to the 8th times v to the 3rd times v to the 1st. 8 plus 3 is 11. 11 plus 1 is 12. So this would be 50 v to the 12th power. Number 6, we have to square negative a to the 6th b. And in order to do that, first we have to understand we're going to be squaring that negative. Negative 1 squared, and then a to the 12th, b to the 2nd, plus 9a to the 12th, b to the 2nd. And negative 1 squared is really positive 1. So this is positive 1a to the 12th, b to the 2nd, plus 9 of them, a to the 12th, b to the 2nd. These are like terms. We can add 1 plus 9 together, and our final answer would be that. Number 7, we've got a power rule right here. We got to simplify that first. This negative 2y to the 4th gets multiplied by x squared y to the 6th. We still have to simplify that. So simplifying, I know my handwriting's so sloppy, I'm sorry. For this problem here, we have negative 2x squared and then y to the 10th when we combine using the power rule. And then when we have minus 13 more of them, altogether it's going to be negative 15 x squared y to the 10th. For number 8, we just have a quotient rule here. For the r's, 6 minus 5 is 1, so we have r to the first power. For the s's, 7 minus 4 is 3. And for the t's, 2 minus 2 is 0. Anything to the 0 power just equals 1, so our final answer would be r s to the third. Number 9, we have to square the numerator. So negative 3 gets squared, that turns into a positive 9, since negative 3 times negative 3 is positive 9, and then it's going to be x to the 12th. Over 5 times 3 is 15, and then x to the third times x to the third, that's going to be x to the 6th, since we add those. We then simplify 9/15 normally. We can divide both of those by 3, so we can simplify that to be 3/5. And then using the quotient rule, 12 minus 6 is 6. So we can write our answer like this, 3/5 x to the 6th, or you can keep your answer as one single fraction. Simplify 9/15 to be 3/5, and then you would have x to the 6th power up top, and it would be one single fraction answer. Either are correct, but I kind of like the second way better. But it doesn't matter, they're both right. Number 10, we've got a power rule. I see that on the outside. I kind of like simplifying that first in this problem, so I'm going to do that. It's going to turn into 4 squared, x to the 8th, y to the 4th, all over 6 squared, x squared, y squared. From here, then I am going to simplify everything that I can. Now, 4 squared is 16. So this is going to be 16 x to the 8th, y to the 4th, over 6 squared is 36, x squared, y to the 2nd. And you could use your calculator here. So you can divide 16 by 36 right in the calculator, hit math, enter, enter. Or if you know that they're both divisible by 4, 16 divided by 4 is 4. 36 divided by 4 is 9, so 4/9. And then for the quotient rule, for the x's, it's going to be x to the 6th, and then y to the 2nd. So this is one way to write your answer. Another way, you can leave it in one single fraction as 4 x to the 6th, y to the 2nd, all over 9. For number 11, we would multiply 7 times 3 in the numerator, that's 21, and then use the product rule, adding the k's exponents, it's going to be negative 10, over 6k squared. All right, so 21/6, both of these are divisible by 3. So I would divide 21 by 3 and get 7, 6 divided by 3 and get 2. And then when I use the quotient rule, negative 10 minus 2 more is negative 12. That answer starts up in the numerator. So when you're simplifying it, the answer ends up in the numerator every time you use the quotient rule. But because it's a negative 12, that means I need to bump it back down to the denominator. So it's going to be 7 over 2 k to the 12th power, which makes sense if you understand that we could also move this down right now, that negative 10, and then it would get added with the k squared in the denominator, but would be positive at that point. Number 12, we have negative 9/27, and we can simplify that down to negative 1/3. And then here's the thing, when we use the quotient rule, 8 minus 10 gives me a negative 2, so you're left with n to the power of negative 2. Now, negative 1/3 times n to the power of negative 2, you're going to want to write this as one single fraction. The fraction's numerator is going to be a negative 1, and the denominator is going to be that 3 that was a part of the negative 1/3, but then the n to the negative 2 comes down to the denominator and turns into n squared, positive n squared in the denominator there. So your final answer would be negative 1 over 3n to the 2nd. For number 13, we've got the power rule to complete in the denominator first. So this is going to be a12, b to the negative 3rd, all over. This is going to be a to the negative 4th, b to the negative 4th. And using the quotient rule here, 12 minus negative 4 is really 12 plus 4, so it's going to be a to the 16th. And negative 3 minus negative 4 is really negative 3 plus 4, and that's positive 1. So it would be a to the 16th times b to the 1st. For number 14, A lot of stuff, it looks a little confusing here, especially with the fractions, but don't worry. 3/4, let's add the m's together, m to the 12th, and then the n's, n to the 15th. And then we've got a power rule here, minus 1/2 to the 3rd power is 1/2 times 1/2 times 1/2. In fraction form, that's 1/8. And then that'll be m to the 12th, n to the 15th power. We have like terms here. We have m to the 12th, n to the 15th in both, so we can go ahead and subtract these. 3/4 is the same thing as 6/8. 6/8 minus 1/8 is 5/8. So you can write your answer as 5/8 m to the 12th, n to the 15th. Or you can write it out as one single fraction. That would be 5m to the 12th, n to the 15th, all over 8. And then number 15, we've got here power rule, product rule, combining like terms. Let's see. -4 squared is positive 16. Y to the 3rd to the 2nd is y to the 6th. And then we have times x to the 3rd, y to the 12th. And then plus 7, x to the 3rd, y to the 18th. When we combine the y's here on the left-hand side, we'll get the same exact like terms. We're going to get 16, x to the 3rd, y to the 18th. Plus 7, x to the 3rd, y to the 18th, and 16 plus 7 is going to give me 23, x to the 3rd, y to the 18th. Moving right along, second page, we've got some geometric applications. Finding the perimeter and the area. For a perimeter, you need to add up all the sides. Opposite side lengths are going to be equal, so when we add these up, we'll have 4x squared y plus 4x squared y. That's 8x squared y. And then plus 13x plus 13x is 26x. That would be your answer for the perimeter. In any order, you could also have 26x plus 8x squared y. The area you have to multiply length times width. So we would multiply 4x squared y times 13x, and 4 times 13 is 56, and x squared times another x here is going to be x to the 3rd, and then y. So that would be your area. The area of a trapezoid is a little bit trickier. We've got here like bases, double bases. We've got base 1 and base 2, and the formula is take 1/2, multiply by the sum of the bases. So we add these two together. 2a cubed b plus 9a cubed b is 11a cubed b. And then we multiply that by 6a squared. Alrighty. So personally, when I am using a formula like this that has a lot of different things going on, I'll take the 1/2, 11, and 6, multiply all those first. If I don't have a calculator on me right now, so I'm just kind of doing this in my mind, 1/2 times 6, that's 3. 3 times 11 is 33. So that can be done in your head, 33. And then this is going to be a to the 5th power. And then we've got b to the, oh no, so this is a 6. I'm thinking that's a b. So it's just going to be 33a to the 5th power times just a single b for our area. All right, moving on. Scientific notation. So when we are adding and subtracting numbers that are in scientific notation, those numbers have to have the same exponents as well as the same base. So if you notice, number 18, I changed that little number to be a -5 so that it would have the same base, the same exponent, I mean. So when we add these together, 8.6 plus 6.7 is 15.3. And we get 15.3 times 10 to the -5th. But that's not okay. We cannot have these numbers like that for scientific notation. Only one number in front of the decimal point. So when we move it to the left, what ends up happening, left add, if we're using this, Lars, left add means we have to add 1 to -5, and -5 plus 1 is -4. So this would be the final answer. Number 19, we're subtracting. I know it's kind of weird, but you're allowed to have a negative scientific notation number. 3.5 minus 9 is -5.5. So this will be -5.5 times 10 to the 3rd. For 20, we're multiplying. 5.6 times 4.5 is 25.2. Adding the exponents, we would get times 10 to the 10th, and we would have to move this. It has to move over to the left, and because we're moving it to the left, we add 1, so it's going to be 2.52 times 10 to the 11th. Also multiplying a number 21, when we multiply these numbers, we get 67.64 times 10 to the, add the exponents, -9. We've got to move this over 1 to the left, so it's going to be times 10 to the -8th, since we would add 1 to it. 22 is a division problem. Be careful. 3.9 divided by 4 is 0.975. And when we are simplifying the exponents, we subtract. -12 minus 4 is what you would do, and -12 minus 4 is -16. All right, once we do that, then we have to move the decimal point over. So 9.75 times 10 to the, we're moving it to the right this time. So since we're moving it to the right, we subtract 1, so it's going to be to the -17th power. Next problem here, 1.75 divided by 5 is 0.35. And we're subtracting. 5 minus -3 is really 5 plus 3, which is 8. We need to move this decimal to the right. And since we're moving it to the right, we subtract 1. So it's going to be times 10 to the 7th as our final answer here. And then 24, a little application question with our scientific notation. So the continent of North America has an area of approximately 9.4 times 10 to the 6 square miles. The area of Asia is approximately 1.74 times 10 to the 7th. Approximately how many times larger is Asia than North America? If we want to figure out how many times larger Asia is than North America, that means Asia is the bigger number, the bigger area. So we need to take Asia's population and divide it by North America. Okay, so Asia's population is actually this number here. We would take 1.74 times 10 to the 7th, and we would divide it by North America's number, which is here. And 1.74 divided by 9.4 does not work out nicely. It's like an irrational number, but if I wrote down the first 4 digits, it would be 0.1851. When I use my exponent rules, the quotient rule says subtract. 7 minus 6 is 1. I can't leave my answer like this, so I would have to move my decimal point over 1. 1.851 times 10 to the, but when I move it over to the right, I subtract, so it's going to be times 10 to the 0. Remember, 10 to the 0 power really just equals 1. So this means that it's 1.851, which means it's 1.851 about times bigger.